Landslides are one of nature's most terrifying forces. They're so sudden. One minute you have a stable mountainside. The next, it's all gone. But what if we could see them coming? We're going to dive into a totally groundbreaking new way of thinking that uses layers of high-tech sensors to see the unimaginable before it ever happens.
I mean, really, think about that question. How do you predict a collapsing mountain? A slope can be perfectly stable for thousands of years, and then it just lets go. How could anyone possibly know it was about to fail? Well, that's exactly the challenge that this new wave of science is tackling head-on.
And look, this isn't just some interesting academic puzzle. For millions of people around the world, people whose homes are nestled right at the base of steep slopes, finding the answer to that question is, quite literally, a matter of life and death. The stakes really don't get any higher.
So, where do you even start? I mean, you can't put every single hillside in the country under a microscope, right? So the first step is all about going big, looking at the whole picture, so you can find the handful of small, really dangerous places. It's about working smarter, not harder.
The logic here is just brilliant in how efficient it is. Instead of wasting a ton of time and money, the whole strategy is two-tiered. First, you cast this really wide net using data that's already out there for the whole country. And only then do you zoom in on the problem spots with all the expensive, high-tech gear.
Okay, so let's break that down. Step one is about creating this huge, nationwide hotspot map. They do this by feeding all sorts of data, geology, rainfall patterns, how steep the slopes are, into machine learning algorithms. And what comes out is a map that flags potential trouble spots. Only then, once they have that map, does step two kick in, sending in the advanced drones to get a really close look at those specific high-risk areas.
And this is where things start to feel like science fiction. Once a hotspot is identified, they send in the drones, and their whole mission is to build this unbelievably detailed 3D picture of the slope's surface. Now, to get the full picture, they actually use two different technologies that work together perfectly. First up is photogrammetry. It basically stitches together thousands of photos to build a 3D model that's packed with color and texture. But, of course, trees and bushes can hide the ground. And that's where LiDAR comes in. It shoots out tiny laser pulses that can actually get through the leaves and branches to map the true ground surface underneath. You put them together, and you get a perfect 3D model.
Okay, so having a perfect 3D model is great, but then you have to make sense of it. And that's where AI becomes this crucial partner. These AI algorithms are trained to pore over these massive 3D models and automatically spot tiny little fractures and weaknesses that even a trained geologist might miss with the naked eye.
But here's the thing. A landslide isn't just about the shape of a slope. It's also about the actual health of the rock itself. So this next layer of the investigation goes even deeper. It's like giving the mountain a health scan to find its weakest points. The key idea here is something called rock weathering. Just think about it. Over hundreds or thousands of years, rain, ice, and just exposure to the air slowly changes the rock's chemistry. It starts to break down its internal structure, and most importantly, it gets weaker, a lot weaker, and way more likely to fail. And the effect of this weathering is just dramatic. Fresh rock has 100% of its strength, but as it gets weathered, that strength just plummets. A highly weathered rock might have only a quarter of its original strength left. That makes it a ticking time bomb for a collapse, so finding these zones is absolutely critical. So how in the world do you spot this weathering from a drone flying overhead? Well, you use this amazing tool called a hyperspectral camera. Seriously, think of it like a medical scanner for the mountain. It sees light that we can't see, and it can pick up the unique chemical fingerprints of the specific minerals that form when rock starts to decay. It can literally see weakness. All right, so we've scanned the surface in 3D, and we've checked its chemical health. But there's one last place to look for clues, and that's underground. This is the final and maybe the most important layer of the whole investigation. Because, what we see on the surface is just part of the story. The real trigger for a huge landslide is often buried deep under the soil, where water can pool up and hidden cracks can spread. So the question is, how do you see what's going on down there without digging up the whole mountain? The answer is ground-penetrating radar, or GPR. By flying a GPR sensor over the slope, scientists can basically create a map of everything happening underground. It shows them how thick the layer of loose dirt and rock is, it pinpoints where the solid bedrock starts, and, this is the big one, it can spot hidden pockets of water and zones of fractured rock. Those are massive red flags for a potential slide. Now, using this tech is not easy. To get a good signal, that GPR sensor has to fly incredibly low, like just 1.5 meters above the ground. And trying to do that safely over a steep, tree-covered, bumpy hillside, well, that's a huge engineering challenge. It takes really advanced drones with sophisticated terrain-following systems just to keep from crashing.
So let's put this all together. The real magic here isn't one single piece of technology. It's about how they all fit together, how all these different layers of data are integrated into one powerful, predictive system.
So you can see how it builds, right? You start with the massive big-picture view from the national screening, then you zoom in with drones for a super detailed 3D model of the surface. After that, you scan the rock's health with those hyperspectral cameras. And finally, you peek under the ground with the radar. Each step just adds another, more detailed piece to the puzzle.
And here's the payoff. This is the whole point. This integrated system represents a massive shift in how we deal with landslides. We can finally move away from just reacting to disasters after they happen and move towards a future where we can actually predict the most dangerous slopes and do something about them before they fail.
And that leaves us with a pretty cool thought, doesn't it? This whole multi-layered approach was designed for landslides. But what else could it be used for? What other invisible dangers, like crumbling bridges or hidden sinkholes? Could this combination of technologies help us see before it's too late?